Hello, Sir Ilham and friends. We are from Group 1, consisting of Christabel Jenis Emmanuel, Muhammad Arik Sakif, and Raffi Mulya Putra, are going to be discussing about rocket accidents and SpaceX innovations that are related to those accidents.
SpaceX, the aerospace manufacturer and space transformation company founded by entrepreneur Elon Musk, has introduced a number of innovations in rocket science. Some of these innovations include reusable rockets, which is one of the SpaceX most significant innovations is its ability to reuse rockets. SpaceX Falcon 9 rockets has the ability to land back on Earth after launching into space, so it can be relaunched rockets at a fraction of the cost of traditional space flight. Next is Super Draco engines. The Super Draco engines are the key component of SpaceX Crew Dragon spacecraft. They are capable of providing 120,000 pounds of thrust each and are designed to quickly and safely transport astronauts away from the rocket to event of an emergency during launch. Third is grid fins. Grid fins are used by the Falcon 9 rocket to guide it back to Earth after launch. Mars-bound rockets. SpaceX is currently developing a Starship rocket which is designed to transport human and cargo to Mars. The last one is propulsive landing. The Falcon 9 rocket is capable of landing back on Earth in a controlled manner using its engine. This technology has made it possible for SpaceX to recover rockets and reuse them significantly during the recoast of space travel.
The Apollo-1 tragedy. In 1961, the former President of the United States of America, John F. Kennedy, exclaimed that he wanted America to land astronauts on the Moon and that he wanted it to happen during the 1960s. Following the former president's wish, NASA, the National Aeronautics and Space Administration, carried out the Apollo program to send people to the Moon. There were in total 11 Apollo flights, with the first being in 1969 and the last in 1972. To be more specific, the first four flights were done to test the spacecraft, while six of the seven other flights landed on the Moon, with the most popular one being Apollo-11, the first landing on the Moon. However, out of all the successful flights remained one tragedy that befell the Apollo program. Apollo-1, initially designated as AS-204, was the very first crewed mission of the Apollo program. It was originally planned to launch on February 21, 1967, as the first low Earth orbital test of the Apollo Command and Service Module. However, on January 27, 1967, a month before the launch, a flash fire occurred in Command Module 12 during launch rehearsal tests, tragically killing all three crew members: Command Pilot Gus Grissom, Senior Pilot Ed White, and Pilot Roger B. Chaffee, and ultimately destroying the command module. And so, following the tragedy, Apollo-1, the name given by the crew themselves, was made official by NASA in honor of their deaths. Immediately after the incident, NASA tried to determine the cause of the fire while both chambers of the United States Congress conducted their own committee inquiries to oversee NASA's investigation. The ignition source of the fire was determined to be electrical. A NASA review board found out that it was caused by a stray spark, most likely from damaged wires near Grissom's couch. The fire spread rapidly due to combustible nylon material and the high-pressure pure oxygen cabin atmosphere. And unfortunately, the only means of escape the crew had was prevented by the complex two-part hatch door that can take at least 12 seconds to open, along with the high internal pressure of the cabin, which made opening the hatch much harder. The preparedness of the test supervisors also contributed to the disaster of Apollo-1. Because of the fact that the rocket was unfueled, the test was not considered hazardous, and so emergency preparedness for it was poor. After the tragedy, several changes were made to the design of the Apollo spacecraft to improve crew safety. The flammable oxygen environment for ground tests was replaced with a nitrogen-oxygen mix, with 40% nitrogen and 60% oxygen. Flammable items were removed, and most notably, the two-part hatch was replaced with a single unified hatch so that it would open in mere seconds when the crew needed to get out in a hurry. The events of Apollo-1 was a disaster that could have been prevented with more care and thought put to it. But thankfully, the tragedy of Apollo-1 gave insightful information about the hazards of spacecrafts. Thankfully, today, the spacecrafts are safer and more reliable for the crew that will pilot it. Take for example the Dragon capsule. The SpaceX Dragon capsule is a spacecraft designed and built by the private space exploration company SpaceX to transport cargo and crew to and from the International Space Station, the ISS. Unlike the spacecraft of Apollo-1, the SpaceX Dragon capsule has more refined hatch systems along with specific procedures and safety protocols that must be followed to ensure the safety of the crew and the spacecraft. The hatch of the Dragon capsule is designed to be opened and closed by the crew. Before opening the hatch, the crew must first verify that the spacecraft is in a safe configuration and that the cabin pressure is at a safe level. They must also follow specific procedures for depressurizing the cabin, opening the hatch, and exiting the spacecraft. Additionally, the crew is trained to handle emergency situations that may require them to quickly exit the spacecraft. In such cases, the crew can open the hatch using a manual override system, which is designed to allow them to exit the spacecraft in the event of an emergency. However, this is only done in extreme emergency situations, as opening the hatch manually can pose risks to the crew and the spacecraft. Therefore, the crew is trained extensively on the proper procedures for opening the hatch in both normal and emergency situations, ensuring that the events of Apollo-1 will never happen again. Next is the Soyuz 1 tragedy. The tragedy of Soyuz 1 started with political pressure. Soviet leaders apparently wanted to celebrate Vladimir Lenin's birthday in the 22nd of April with the Soyuz launch. In comparison, the Soyuz program was similar to NASA's Apollo program, as they are both aimed at an eventual lunar landing. And so, on April 23, 1967, the Soviet Union announced the launch of a new generation spacecraft called Soyuz 1 as part of the Soviet lunar program. Soyuz 1 was a crewed spaceflight that was part of the Soviet lunar program, launched into orbit carrying cosmonaut Colonel Vladimir Komarov. It was the first crewed flight of the Soyuz spacecraft program. However, the flight was ridden with technical problems and eventually ended in tragedy, making Colonel Komarov the first ever person to die on a space mission. Komarov's name was included on a commemorative plaque left on the Moon during the 1971 Apollo 15 landing. The plaque honored 14 astronauts and cosmonauts, including the Apollo 1 crew, who died in the pursuit of space. The Soyuz 1 mission experienced a number of malfunctions that led to its tragic outcome. The exact cause of the failure is still debated, but it is believed that a number of factors contributed to the accident. One of the primary causes of the failure was a design flaw in the spacecraft's parachute system. The Soyuz 1 capsule was designed to be brought back to Earth using a series of parachutes that would slow its descent and allow it to land safely. However, during the mission, one of the main parachutes failed to deploy properly, which caused the spacecraft to crash into the ground at high speed, killing the cosmonaut inside. There were also a number of other technical and operational issues that contributed to the failure of the mission. For example, the spacecraft's guidance system malfunctioned, which made it difficult for the cosmonaut to control the spacecraft during re-entry. There were also concerns about the spacecraft's heat shield, which was found to be thinner than originally planned, and may have contributed to the spacecraft's ultimate failure. Finally, there were also political and organizational factors that may have contributed to the failure of the mission. At the time of the Soyuz 1 mission, the Soviet Union was engaged in a Cold War space race with the United States, and there was significant pressure on the Soviet space program to achieve ambitious goals in a short amount of time. This may have contributed to rushed decision-making and a lack of attention to safety and quality control. Overall, the failure of the Soyuz 1 mission was a tragic reminder of the risks and challenges involved in space exploration and led to significant changes in the Soviet space program's approach to safety and risk management. The tragedy of Soyuz 1 was a huge setback for the Soviet space program, but it wasn't the end of the Soyuz missions. Design flaws were uncovered and fixed, and eventually the Soviet space program had a reliable launch and recovery system. We still use it today. One of the main changes that was made was to improve the design and testing of the spacecraft's parachute system. The parachute system was redesigned to make it more reliable and effective, and more rigorous testing procedures were put in place to ensure that it would function properly during a mission. The Soviet space program also made improvements to the spacecraft's guidance system, which had malfunctioned during the Soyuz 1 mission. The guidance system was updated and tested extensively to ensure that it would function properly during future missions. In addition to technical improvements, the Soviet space program also implemented changes to its organizational structure and decision-making processes. Safety and quality control were given a higher priority in the program, and more rigorous procedures were put in place to ensure that all aspects of the program were properly tested and verified before being used in a mission. Overall, the changes made by the Soviet space program after the Soyuz 1 mission helped to improve the safety and reliability of the program and enabled it to continue making significant contributions to the field of space exploration. Today, the Soyuz spacecraft is still used by Russia to transport astronauts to and from the International Space Station, and it remains one of the most reliable and proven spacecraft in the world. Just like the event of Apollo 1, this tragedy could have been avoided if the circumstances were better and if the Soviet had planned more carefully without thinking of the political space race with the Americans. Thankfully, the tragedy of Soyuz 1 helped the Soviets and everyone else understand the risks and precautions they need to keep in mind when landing a spacecraft. For example, the SpaceX Dragon capsule has a landing system designed to be safe and reliable for returning astronauts to Earth. The Dragon capsule uses a system of parachutes and thrusters to slow its descent and land gently in the ocean. The system has been extensively tested and has been used successfully in multiple missions, including crewed missions to the International Space Station. The landing sequence begins with the deployment of drogue parachutes, which slow the spacecraft's descent and stabilizes its orientation. This is followed by the deployment of main parachutes, which further slow the spacecraft's descent and ensure a gentle landing in the ocean, similar to the landing system of Soyuz 1. However, once the spacecraft is close to the ocean surface, it uses a series of thrusters to control its descent and ensure a safe touchdown. The Dragon capsule also includes a number of safety features, such as a flotation system that keeps the capsule upright in the water and allows their astronauts to be rescued quickly. Overall, the SpaceX Dragon capsule landing is considered to be a safe and reliable method for returning astronauts to Earth. The landing system has been extensively tested and has been used successfully in multiple missions, and SpaceX continues to refine and improve the system to further increase its safety and reliability so that hopefully the tragedy of Soyuz 1 won't happen again.
Move on to Soyuz 11 accident, an accident which involved the only 3 men who have died in space. Before going to much more detail about the accident of Soyuz 11 which caused its crew to die in space, I'm going to provide a little bit of introduction on how Soyuz 11's mission was constructed. In the midst of the space race between the United States and the Soviet Union, the Apollo mission made history by landing the first humans on the moon on July 20, 1969, making the Soviet Union, whose original plan was to beat the United States to the moon landing, turned their attention away on focusing to build the world's first space station instead. On April 19, 1971, the Soviet Union achieved a major milestone in space exploration by launching the world's first space station, Salyut 1. Just 3 days later, after Salyut 1 was launched, Soyuz 10 was sent to dock with the space station. However, the crew encountered latching problems and failed to dock successfully. It is confirmed that the latching problem was caused by the failure of the ship's computer. Did not want to abandon Salyut 1, the Soviets prepared to try again with the launch of Soyuz 11 on 6 June 1971. Launched from the Balkany Cosmodrome in Kazakhstan, their mission was to dock with Salyut 1 and run a few experiments there. Initially, the original crew member for the Soyuz 11's mission consisted of Alexei Leonov, Valery Kubasov, and Pyotr Kolodin. However, just days before the launch, a medical examination revealed that Kubasov was diagnosed with tuberculosis. As a result, the primary crew was replaced with the backup crew, which consisted of Georgy Dobrovolsky, Viktor Patsayev, and Vladislav Volkov. They have a call sign of Yantar or Amber in English. Georgy Dobrovolsky was selected to lead the mission and assume the role of the commander, and Viktor Patsayev would serve as a research engineer of the Soyuz 11's mission. Both of them have had no spaceflight experience before, while the third crew member, Vladislav Volkov, had previously flown aboard Soyuz 7 2 years prior to this mission, would serve as a flight engineer. The docking process, which was initially automatic and then reverted to manual control, lasted for 3 hours and 19 minutes. Eventually, the crew successfully entered Salyut 1 on June 7, 1971, marking the first time in history that humans had crewed a space station. With the Soyuz 11 spacecraft connected to Salyut 1, the cosmonauts had approximately 100 cubic meters of space available to them, which they then used to conduct more than 140 scientific experiments. During the 11th day of their mission, an electrical fire broke out, but the crew was somehow managed to extinguish it. Despite this incident, the crew managed to stay in space for a total of 23 days, which set a new record for space endurance until the launch of Skylab in 1973. The Soyuz 11's mission was widely broadcasted, and the state media provided regular updates to the public. And then we move on to the problem chapter. In this chapter, I will give a detailed explanation on how the Soyuz 11's mission would end up as an accident. After spending approximately 23 days in space, on June 30, 1971, the Soyuz 11 spacecraft began its descent to Earth. The capsule landed safely in Kazakhstan. However, the Soviet workers who checked on the capsule were shocked to find that all 3 cosmonauts were dead inside. The military hospital at the Bedenko Medical Center determined that the cause of death for the cosmonauts was the hemorrhaging of blood vessels in their brains, along with a smaller amount of bleeding under their skin, in their inner ears, and in the navel cavity. These injuries resulted from the exposure to a vacuum environment, which caused the oxygen and nitrogen in their bloodstream to bubble and rupture their blood vessels. The human body experiences various effects when exposed to the vacuum of space. The most apparent impact is the absence of oxygen, which can result in suffocation. Additionally, the boiling point of bodily fluids decreases below the regular body temperature, which means that saliva on the tongue and blood would boil because of the low atmospheric pressure of space. The cosmonauts died due to a depressurization of their spacecraft during the re-entry. Officials later determined that air leaked from the ventilation valves located behind the control panel. The 6 explosive cartridges and 6 explosive bolts that held the orbital module and the descent module together fired simultaneously instead of sequentially, which emitted an unexpected shock that caused the valves to become loose. The valves that opened at 105 miles above the Earth's surface instead of 2.7 miles as planned exposed the crew to the vacuum of space. Dobrovolsky's body was discovered in the descent module, where his body position suggested that he was attempting to unstrap himself from his seat and move toward the valve to shut it off. However, he was unable to act quickly enough as oxygen leaves his body, and by 110 seconds after exposed by the vacuum, all three cosmonauts had passed away. Apparently, these are the 5 flaws of the Soyuz 11's mission. First, the valve design did not consider the impact of simultaneous firing of explosive balls. Second, there were no alarms associated with the valves, causing the crew to waste valuable time searching for the source of the leak. Third, the valves were located behind the control panel, making them impossible for the crew to access. Fourth, the valves lacked a backup closure mechanism, preventing the crew from fixing the leak. Fifth, the cosmonauts did not wear pressurized spacesuits due to limited space in the descent modules. In the resolution chapter, I will be explaining some of the improvements made after the Soyuz 11's accident. Some of the improvements made to Soyuz include upgrading the reliability of valves in the face of shock loads to enhance safety measures. Emergency pressurization equipment was added to the spacecraft also. Furthermore, a manually operated valve was placed in the ventilation inlet and outlet, which could be accessed by the crew in case of emergency. Following the tragic incident of Soyuz 11, the Soyuz spacecraft underwent significant redesigning. One of the changes made was reducing the number of crew members from 3 to 2. This modification created enough space for the two cosmonauts to wear spacesuits during launch and landing, improving their chances of survival in the event of a depressurization accident. The Soyuz capsule did not carry three crew members again until 1980, when it was redesigned to accommodate three cosmonauts wearing lightweight pressure suits. Before moving to the SpaceX innovation, it needs to be reminded that spacesuits were designed to mimic atmospheric pressure and shield astronauts from sudden pressure loss by compressing their bodies with gas. It is suggested that spacesuits could potentially have been a solution to the cabin depressurization accident that happened during the Soyuz 11 mission. Okay, moving on to the SpaceX innovation. The SpaceX innovation that I'm gonna be reviewing in the next few slides would be its spacesuit, since it will save astronauts in the event of cabin depressurization, as it happened in Soyuz 11's mission. SpaceX has been working on improving spacesuits for their astronauts to ensure their safety and comfort during spaceflight. The company's new spacesuits are designed to be lighter, more flexible, and of course safer. And here are some features made by the SpaceX to their spacesuits. Spacesuits were typically designed in fixed sizes due to how expensive they are. Spacesuits that are not customized for individual astronauts can lead to discomfort and injury. However, SpaceX creates fully tailored spacesuits for each crew member, which offer numerous benefits including improved mobility and safety during space missions. The SpaceX spacesuit has crisscross tensioners on every joint to provide added support and facilitate movement. The tensioners assist the astronaut in bending the joint inwards, and then the suit's air pressure aids in extending the joint back to its original position. This mechanism is the same as how spiders move their legs. They only use muscle to flex their limbs inward and rely on hydraulic pressure to go back to the initial position. The SpaceX has designed its spacesuit to be equipped with 40 kilopascals of pressure, which is nearly half of the Earth's atmospheric pressure, and is higher than other spacesuits. While the primary purpose of the suit is to protect the crew from cabin depressurization, the suit is also equipped with a range of features, such as cooling, communication system, hearing protection, and flame resistance, making it a durable tool for space exploration. When the SpaceX crew enter the capsule, the only thing they need to do is sit and connect their suits to the umbilical, which is attached to the chairs. The umbilical is a big cable that provides everything the suit needs, such as communication electronics, cooling air, and gas to pressurize the suit. It helps to control the astronaut's temperature and pressure throughout the mission, and this way the suit will be lighter and less wiry. So basically, the umbilical is a single point that makes it easier for the suit to function properly. SpaceX has designed the gloves of their spacesuits to be compatible with the touchscreen technology, allowing the crew to work while wearing the gloves. Additionally, the gloves also meet the same standards as the rest of the suit, which is providing sufficient pressure support. While for the space shuttle suits, the helmet, gloves, and headset are all separated and need to use bulky rings to assemble all of them. And not only that, assistance from multiple technicians are needed, and it took over 20 minutes to wear the suits. In contrast, the gloves and helmet of the SpaceX suit are already attached, and the headset is built into the helmet, which allows the astronauts to put on the suit by themselves in just a few minutes. Lastly, the helmet of the SpaceX suit has multiple roles, such as shielding the crew's head, holding gas, containing microphones, and controlling the suit's pressure through its valves. And that's it, the detailed explanation of the Soyuz 11's accident.
The Challenger 1986. The Challenger was a NASA space shuttle that launched on January 28, 1986 with a crew of 7 members, including Krista McAuliffe, a New Hampshire schoolteacher. The launch was broadcasted live on television and millions of people around the world watched as the Challenger lifted off the Kennedy Space Center in Florida. Just 73 seconds into the flight, a seal on the solid rocket boosters failed, which caused hot gases to escape and ignite the main fuel tank. The explosion destroyed the shuttle and killed all the crew members. The Challenger disaster was a significant setback for the NASA and the U.S. space program, leading to a 2.5 hiatus and in the shuttle program and re-evaluation of the agency's safety procedures. The problem of the Challenger disaster of 1986 had several causes. First, the primary physics that problem that led to the Challenger disaster was a failure of the O-ring seals on the solid rocket boosters that were used to lift the shuttle into space. The ring seals were designed to prevent hot gases from escaping the solid rocket boosters during launch. However, during the Challenger launch, the unusually cold temperatures caused the O-ring seals to become brittle and fail to seal properly. The failure of O-ring seals was related to the thermal expansion and contraction, a fundamental principle of physics that describe how materials expand and contract at different rates in response to temperature changes. The cold temperature during the Challenger launch caused the O-ring seals to contract more than expected, allowing hot gases to escape and damage the shuttle. The combination of cold temperatures and stress on O-ring seals led to the catastrophic failure of the shuttle, resulting in the tragic loss of all members. So the solution is redesign the O-ring seals. Following the Challenger disaster, NASA and its contractors undertook a major redesign of the O-ring seals. There are some key points of it. First, material selection. NASA researchers and engineers worked to identify new materials that could better withstand an extreme temperatures and pressure condition of launch. This involved testing a wide range of materials, including high-performance polymers and and others materials to find the most suitable option. Second is design optimization. Engineers also work to optimize the design of O-ring seals to reduce stress and improve sealing performance. This involves adjusting the shape, size, positioning of the seals to minimize stress and improve contact with the rocket boosters. Third is manufacturing improvement. Finally, NASA and its contractors implemented improvements in the manufacturing process for their O-ring seals to improve consistency and reduce the risk of defects. This involved using more precise manufacturing equipment and developing new quality control measures. There are several innovations by SpaceX that could potentially have been solution for the Challenger disaster in 1986. There is reusable rockets. SpaceX has developed rockets that can be reused multiple times, which reduce the cost of space flight and eliminates the need of solid rocket boosters. Second is SpaceX Merlin rocket engines. Used in Falcon 9 and Falcon Heavy rockets, they are simpler and more reliable than the Space Shuttle's main engines. Next is outermost landing. SpaceX Falcon 9 rocket is capable of outermost landing back on Earth, which could potentially have eliminated the need of Space Shuttle's complicated landing procedures. Last one is autonomous flight control. SpaceX rockets are equipped with advanced autonomous flight control systems that allowed for greater precision and safety during launch and landing. This technology could have potentially prevented the problems that led to the Challenger disaster, such as the failure of solid rocket boosters. The Space Shuttle Columbia disaster occurred on February 1, 2003, resulting in the loss of all seven crew members aboard the shuttle. Columbia was the first operational shuttle in NASA's fleet and had completed 27 successful missions prior to the disaster. During the shuttle's final mission, a piece of a foam insulation broke off from the external fuel tank during launch and struck the leading edge of the left wing. NASA engineers did not believe that foam strike poses a serious threat to the shuttle. During the shuttle's re-entry, the damage caused by the foam strike allowed hot gases to enter the wing, causing it to break apart. The shuttle disintegrated over Texas and Louisiana. After the disaster, NASA conducted an extensive investigation revealing a culture of complacency, a lack of effective communication between different departments, and a failure to recognize and address known risks and technical issues. So the main problem is the foam strikes. The foam insulation broke off the external fuel tank and hit the left wing of the Columbia shuttle during its launch, and the damage caused by the foam strike left the left wing vulnerable to high temperatures and extreme forces during re-entry. During re-entry, hot gases entered the damaged left wing and caused the entire shuttle to disintegrate. The investigation found that NASA had not taken enough action to address the risk of from strikes to shuttle's thermal protection system. So, to address this problem of the foam strikes, there are 4 points about it. First, improving inspection and repair procedures for the shuttle's thermal protection system to better detect and repair damage caused by from strikes or other debris. Second is implementing new technologies to detect and monitor the health of the shuttle during flight, such as the use of high-resolution cameras and sensors to detect damage. Modifying the design of the external fuel tank to reduce the amount of foam insulation that could break off during launch and potentially damage the shuttle. Developing a repair kit that could be used by astronauts in space to fix the damaged tiles on the shuttle's thermal protection system. SpaceX innovation could potentially improve the safety of spacecraft to prevent Columbia 2003 disaster. Here there's 3 points, which is advanced heat shield. SpaceX spacecraft are equipped with advanced heat shields that are designed to withstand the high temperatures generated during the re-entry, which could help prevent damage to the spacecraft during this critical phase. Second is propulsion system. SpaceX propulsion system is designed to be highly reliable and safe, which could help prevent failures or malfunctions that could lead to catastrophic events during flight. Third is in-flight monitoring. SpaceX uses advanced sensors and monitoring systems to keep track of the health of its spacecraft during flight, which could help detect any anomalies or damage that could pose a risk to the crew of the mission.